In this video, I'm going to show you how to multiply two binomials together, and I'm going to call this special kinds because I want you to see what happens when your two binomials look almost identical except one tiny difference. One factor has a plus sign and one has a minus sign. So I'm going to call this a special kind because I'm going to show you what is unique that happens here. Now I really like my box method, so I'm going to write my x plus 3 outside my box. And I'm going to write on the other side my x and my minus 3 on the other side, and I'm going to show you what happens when we multiply. So x times x is x squared, x times negative 3 is negative 3x. Now 3 times x is 3x, and 3 times negative 3 is negative 9. Now watch when we combine our like terms. We have x squared, we have a positive 3x, a negative 3x, and then a negative 9. And the two middle terms that we have that are alike here, so if I'm writing it in standard form, meaning my highest power comes first, and then a power on my x would be 1 here. We don't write it, but it would really have a 1. And then another power of 1, and then none, so your number terms always last. What would happen is I'm just left with x squared minus 9 because our middle terms are the same coefficient but opposite signs. Very similar to what we were looking for when we did elimination method for solving a system of equations in chapter 6. So this middle term gets eliminated because it has the same coefficient of 3, but one is a positive and one is a negative, and so that term cancels out. So now we're left with, when we multiply a 2 by 2, we're left with a binomial as well, which is kind of fun. All right, here's another one. Again, same type of binomial being multiplied together, but again, one of them has a plus sign and one has a minus sign. Again, you're going to see something unique happen here. So I'm going to write my first binomial at the top, 3x minus 1, and then my 3x and my positive 1 on the side. And then again, when I multiply, 3x times 3x is 9x squared. 3x times 1 is 3x. Negative 1 times 3x is negative 3x. And negative 1 times 1 is negative 1. Again, if I write out all my terms, we're going to see something happen with these alike terms. So 9x squared, we have a positive 3x, a negative 3x, and a negative 1. And again, you'll notice that our two middle terms cancel out, and I'm left with, for my polynomial when I multiply, 9x squared minus 1. What I'd love for you to do is pause the video and do these two, and then we'll check your work. So for my first binomial, x plus 5, and my second one, x minus 5. So x times x is x squared, x times 5 is 5x, negative 5 times x is negative 5x, and 5 times negative 5 is negative 25. My four terms are these: x squared plus a 5x minus a 5x minus 25. The order of which you write these really doesn't matter, except I would say standard form is a must. And so x squared, then our x to the first power, x to the first power, then no x's, meaning your constant term at the end. Again, our middle terms cancel out when we combine them together, and I'm left with x squared minus 25. Okay, one more here, 2x plus 6, and then a 2x minus 6. So here's my four terms. 2x times 2x is 4x squared. Let me fix that real quick. 2x times 6 is 12x. Negative 6 times 2x is negative 12x. And negative 6 times 6 is negative 36. Now the four terms, if I write them out, I have 4x squared, a positive 12x, a negative 12x, and a negative 36. And if I combine my middle terms, again they cancel out, and I'm left with 4x squared minus 36. I hope you notice something here in all of these examples. Your middle terms canceled out, and in every single example, you're left with, for an answer, a square term minus a square. A square term minus 1 is a perfect square. A square term minus a perfect square, square term minus a perfect square. So it's just kind of unique. I would call this a special kind, but here's multiplying two binomials where one of the factors is a plus and one of the factors has a minus. You get some terms that cancel out.